Hello everyone, hope you are doing well. I am Akshay Barmar, Assistant Professor at LJ Institute of Engineering and Technology in IT/IC Department. Welcome to the video tutorial series of the data communication and the computer networks. Today we will discuss multiple access link and its one type, the random access protocol. Right? So before diving into the session, let's see what we are covering in this particular session. So in that we will cover multiple access links in its type, right? And after that we will briefly discuss about one of its type, the random access protocol. In the random access protocol there are several types, Aloha and CSMA. In the Aloha there are the two subtypes, pure Aloha and the slotted Aloha. And in the CSMA there are the two techniques, CSMA CD and CSMA CA, the collision detection and the collision avoidance. So we will see them in brief, right? So in this particular session, let's start with the multiple access link and its type. So there are the various category of the multiple access protocol. The first one is channel partitioning protocol. In that, it is dividing the channel into the smaller chunk of the pieces, right? That pieces are maybe the time slot, it is that pieces may be the frequency slot, that pieces may be the code slot, right? So that in that divide the channel into the smaller pieces. After each pieces is allocated to the node for the excessive use, right? So there are several kind of channel partitioning protocol is the TDMA, the time division multiple access, frequency division multiple access, and the code division multiple access. We have seen all of them in brief in our previous session, right? The second category of the multiple access link is the random access protocol. So what do you mean by that random access protocol? In that the channel is not divided into the several pieces, right? So in that the channel is not divided in the several pieces, and it is allowing the collision to occur, right? After the collision it is recovered from the collisions, right? So example of the random access MAC is medium access control protocols such as pure Aloha, slotted Aloha, and the CSMA CD and CSMA CA, right? So let's begin the third portion. Third part of the third category of the multiple access link is taking turns protocols. In that nodes take turns, but nodes with more to send can take a longer turns, right? So for example of the taking turn protocols are polling and the token passing, right? So let's begin with an Aloha, right? So in this session we are briefly discuss about the random access protocol, and its first type is Aloha. So Aloha is the earliest random access method. Aloha was developed at the University of Hawaii in the early 1970s, right? Actually it was designed for a radio LAN, right? But on the share medium it can be used, right? So initially the Aloha is designed for a wireless LAN, which is what on the radio waves, but on the shared medium the Aloha can also be used. The main problem in the shared medium is the collision, right? So whenever the two devices are transmitting the data in the transmission media, they are collision, their collision is the major problem nowadays, right? So when more than one station want to transmit the data simultaneously, when more than one station wants to transmit the data simultaneously, there are possibility of the collision there, right? So it can be overcome with the help of Aloha. Aloha has mainly two types, pure Aloha and the slotted Aloha, right? So what do you mean by the pure Aloha and what do you mean by slotted Aloha? Let's discuss about that. So pure Aloha protocol, right? So it allows user to transmit the data whenever they have data to be sent, right? So in the pure Aloha, it allows user to transmit whenever they want to send the data in the link, right? So if they are not sensing that the link is empty, link is idle or not, they are just simply send the data in the link whenever they want to do that, right? The sender wait to see if the collision occurs. If whole message has been to send, right? The sender has to wait to see that if the collision is occurred during the transmission or not, right? After the whole message has been sent, right? So if the collision occur, each station involved waits a random amount of time and then tries again, right? So in the pure Aloha, if the collision occurs, each station involves wait to the random amount of time, and after that the random amount of time they will tries again for the transmission, right? So system in which multiple users share the common channel in a way that they can lead to conflict are widely known as the contention system, right? So whenever two frames try to occupy a channel at the same time, there will be the collision and both will be the garbage, right? If the first bit of the new frame overlap with the last bit of the frame almost finished, the both frame will be totally destroyed and both will have to retransmit later, right? Transmitted later, right? After that, the frames are transmitted at the completely arbitrary time, right? So in that, the frames can be transmitted whenever the sender wants to send that in the transmission media, right? So the frames are transmitted at completely arbitrary times. The throughput of the pure Aloha is maximized when the frames are of the uniform length, right? So if the formula to calculate the throughput of the pure Aloha is S is equal to G into E raised to minus 2G, right? The throughput is maximum when G is 1 by 2, which is 80% of the total transmitted data frames, right? So this is the example. Here we have the four senders: sender 1, sender 2, sender 3 and sender 4, right? The sender 1 is sending the data frame 1.0 and frame 1 to 1.2, right? In that the frame 1.1 is the first frame which is sended by the sender 1, and frame 1.2 is the second frame which is sended by the sender 1, right? After that, in the sender 2, it is sending the frame 2.1 and 2.2 respectively. In that, the frame 2.1 is sended first and 2.2 is the second frame which is sended by the sender 2. Like that, the sender 3 and sender 4 are sending the frames. The frame 3.1, 3.2 is sended by the sender 3, and frame 4.1 and the frame 4.2 which is sended by the sender 4 whenever they want to send, right? So here you can observe that any frame is sended whenever that its respective senders want to send the data. They are not seeing that the channel is ideal or not. There are, right? So if the sender 1 wants to send the data, right? So it want to send the frames in the transmission media. It will directly send the data into the link, right? And it can be the any length of that frames, right? The sender can send that frames whenever they want to send, and it can have the any of the length, right? So here you can observe that there are the two collision occur, right? So in that, the starting portion of the frame 1.2 and the whole frame of the and ending portion of the frame 2.1 are collided. Likewise, the frame 3.1 and frame 4.1 are also the collides, right? So here you can observe that they are collided, right? So that in particular time slot and particular slot, that frames are overlapped, we can say that, right? So that is the collision. In the second collision, the frame 2.2 and the frame 4.2 are collided, right? So in that, the ending portion of the frame 2.2 and the starting portion of the frame 4.2 are collided, right? So that is the collision 2, right? So that's how the pure Aloha is working. In the slotted Aloha, how does it working, right? So in that, there are the it was invented to improve the efficiency of the pure Aloha, as chances of the collision in the pure Aloha is very high, right? Because the sender can send the any length of the frame in the whenever he want to send the data, right? Its disadvantages is overcome with the slotted Aloha. It is invented to improve the efficiency of the pure Aloha, right? The time of the shared channel is divided into the discrete interval that discrete interval is called the slots here, right? So that channel is divided into the slots, right? After that, the sender can send the data in that particular slots only, right? The station can send the frame only at the beginning of the slot, and only one frame is sent in each slot, right? So the channel is divided into that slot, and that slot can be used by the any station. That station can send the frame only at the beginning of the slots, and only one frame is sent in each slot. Here you can observe in the figure that the sender 1, sender 2, sender 3 and sender 4 are there, and here you can observe that its channel is divided into the slots: slot 1, slot 2, slot 3, slot 4, slot 5, slot 6 and so on, right? So here you can observe that the sender can send data only when the beginning of the frame, and they can send only one frame in each particular slot, right? So here you can observe that the frame 1.1 is sent by the sender 1 in the first slot. In the second slot, the sender 2 and the sender 3 are sending the data frame 2.1 and 3.1 respectively. After that, in the third slot, the frame 1.2 and the frame 4.1 is there, right? So it is sent by the sender 1 and sender 4 respectively. In the fourth slot, sender 2 is sending the frame 2.2 in the, and so on, right? So that's how that frames are sent in the slotted Aloha. But what if there are the collision occurs, right? So what is collision then? So whenever in the that particular time slot, and in particular slot, the two senders are sending that frames, that the slot is called the collided slot, right? So we can say that the collision is occurred there. So here you can observe that frame 2.1 and frame 3.1 are overlapped, right? So we can say that there is the collision occurred. Likewise, the frame 2.1 and the frame 4. The frame 1.2 and the frame 4.1 are here in the same slot, right? So we can say that they are also the collided, right? So we can simply discard that and retransmit that slot, right? This is the diagram of the throughput, right, of the slotted Aloha and the pure Aloha. The any station, if any station is not able to place the frame onto the channel at the beginning of the slot, then the station has to wait until the beginning of the next time slot. In the slotted Aloha, the sender can send the data only at the beginning of the time slot. So if he misses that sending the data at the beginning of the time slot, he or she has to wait until the next time slot is there, right? So if the station is not able to place the frame on the beginning of the slot, then the station has to wait until the beginning of the next time slot, right? So this is the throughput of the slotted Aloha. The throughput is maximum when G is equal to 1, which is 37% of the total transmitted data frame, right? So this is about the slotted Aloha. The 30% of the time slot is empty, and 30% is the success, and 26% are the collision there, right? You can observe in the figure there. After that, let's see the CSMA CD. The CSMA with the collision detector. Here CD stands for the collision detector. This technology was developed not only to help to avoid the collision, but also to respond correctly if collision does happen, right? So that's why the CSMA is there. What is CSMA stands for? The carrier sends multiple access is the full form of the CSMA, and CD is stand for the collision detector, right? In the earlier days, the early Ethernet uses the CSMA technique, right, in the duplex mode, right? The coaxial cable and the twisted pair cable are using the CSMA CD protocol. In that, each device sends if the wire is ideal, and if the wire is ideal, then it can send the data into the channel, right? The two computer what if the two computer at the different location sends the wire ideal at the same time, and they are sending the data simultaneously from the two different edges, right? So for an example, here A is there and here B is there, and they are sensing that channel, sensing that wire if it is ideal or not. They both are sensing the wire is ideal at the same time, and both are sending the data. So at that time, what will be occur in this it's their frames are traveling in the transmission media and they are colliding, right? So we can say that the collision will occur at that time, right? So that's how the CSMA detect the collision. If two stations sends the channel to the idle and begin the transmitting simultaneously, they will both detect the collision almost immediately, right? Rather than finish transmitting, they should arbitrarily stop transmitting as soon as the collision is detected. After that, they will wait for the quickly terminating the damaged frame, saves the time and the bandwidth, right? After that, they will wait for the ideal random amount of time, right? So this protocol is known as the CSMA CD. The CSMA with the collision detector is widely used in the LAN and the MAC sublayer, right? So here, after getting that the collision is occur or not, after detecting the collision, they will wait for the random amount of time, right? That nodes will wait for the random amount of time, and after completing that random amount of time waiting time, they will surely retransmit the data they want to send in the channel. So let's see how CSMA CD is working. So right in that figure, you can say that the transmitter, this is the frame, right? So here you can observe that this is the diagram about the CSMA CD. At the point marked at the T0, a station has finished transmitting its frame. Any other station have a frame to send may be not attempt to do so, right? After station detect a collision, it aborts transmission, wait a random period of the time and then tries again, assuming that no other station has started transmitting in the meantime, right? Therefore, CSMA CD will consist of alternative continuation and transmission period, with an ideal period occurring when all stations are quiet, right? So that's about the random access protocol, right? In that we have seen the Aloha and the CSMA. In the Aloha there are the two types, slotted Aloha and the pure Aloha, and in the CSMA we have seen the CSMA CD. CSMA with the collision detecting, right? So that's all about today's session. Thank you for